This presentation is part of a lecture series on the C++ programming language by Michael Adams at the University of Victoria in Victoria, Canada. For those of you who might be interested, a copy of the slides for this lecture series can be downloaded from the website whose URL is given on this slide. In this section, I'm going to discuss the build tool known as Make. At this point, I'd like to briefly introduce a utility that can be used to automate the software build process. In particular, I'd like to introduce a utility called Make. And what Make does is it provides a means to specify rules for how one or more files can be built from one or more other files. And then based on these rules, the Make command can be used to build the files identified in the rules. For example, if we have a set of source code files, and from these source code files, through compiling and linking, we want to produce a number of executable program files, we can specify using Make a bunch of rules which tell us how to use compiling and linking operations in order to generate the program files, the executable program files, from the source code files. So the Make utility is very popular. It's available on many platforms, including probably every variant of Unix in existence, as well as Microsoft Windows, and also more esoteric operating systems as well. It's very flexible. It can handle building multiple programs that may consist of hundreds or thousands of source code files, or even a single program that consists of just one source code file. Furthermore, it can be used to build almost anything. It doesn't necessarily need to be a program. For example, all of the materials for this course are typeset using LaTeX, including these slides that you're looking at now. And LaTeX is basically, for those of you who are not familiar, it's sort of a language which describes a document layout, something kind of like HTML. And in order to produce the final PDF slides that you're actually viewing right now, the LaTeX software has to be run on these LaTeX source files to produce a PDF document. So this is not a program. It's not a program that's being compiled. It's actually a document. But Make can also handle this sort of thing as well, running the LaTeX command to produce a bunch of PDF documents, for example. And one of the most popular implementations of Make is GNU Make, and the website for this GNU Make software is listed here. So if you want to find out a lot more details on what I'm going to cover in this slide and the next few slides about Make, you can find additional details on this website. Now let's examine the Make command in more detail. To begin, I need to introduce some basic terminology, and in particular I need to introduce the notion of a target. So a target is something that can be built by Make. Typically, but not necessarily, this corresponds to a file, such as an executable file or an object file. And the Make command is driven by a data file called a Makefile. And what a Makefile is, essentially a Makefile identifies all the targets, in other words, all the things that can be built by Make, and specifies for each of these targets a set of rules for how to build the target. A Makefile is usually named as either Makefile with a capital M or Makefile with all lowercase letters, and the syntax of the command line for the Make command is Make followed by 0 or more options, which can override some of the default behaviors of the Make command, followed by 0 or more targets to be built. And by default, when the Make command is run, if no option is specified to override the default behavior, the Make command will look for a Makefile called Makefile all in lowercase letters. If this file is found, it will use it. If this file is not found, then it will look for a file called Makefile starting with a capital M. If this file is found, it will use it. If this file is not found, then this is an error, unless some option has been specified to explicitly identify what the name of the Makefile is to be used. If no targets are specified on the command line, in other words, if this target list is empty, the first target that's specified in the Makefile is the target that would be built. And the Make command only builds files that are out of date. And this is a really important property of Make and one of the things that makes it very useful. So for example, if you have a program that consists of 1,000 source code files, and maybe the code has all been compiled and built, and then you change one source code file, and then you want to rebuild the executable program, and you just do this by using the Make command. The Make command will detect the fact that the source code file that you changed, it will determine what other files depend on the change that you've made, the source code file that you've changed. And if, for example, none of the other source code files depend on the file that you've changed, when you run Make, it will only rebuild or recompile that single source code file that you changed. It won't recompile all 1,000 source code files that are associated with the particular program that you're building. So this is a really important functionality because it saves a lot of time when you're actually compiling code. And it does this based on timestamps partially. It looks at the timestamps on files, so it can determine which files are newer than other files. And then lastly, I just want to comment on a few of the options that can be plugged in here. The two most common command line options. The first one is the -n option, which will just have make print out the commands that it would run if you actually ran it for real, but it won't actually execute the commands. And the other option, which is most commonly used, is the -f option, which specifies explicitly what makefile to use. So you can override the default behavior and explicitly identify the name of the makefile that you want to use by using this particular option. As mentioned previously, the make utility is driven off of a type of data file called a makefile. So I need to spend some time describing the format of a makefile. To begin with, let's start with comments. Makefiles allow for comments, and comments start at a hash character and continue until the end of line. So this would be an example of a comment in a makefile. The comment starts at the hash character and it continues until the end of the line. Makefiles also allow for variables, and there are some important variables that are used by built-in rules in Make. There's a variable called cxx, which is the name of the C++ compiler command. For example, it would be G++ if you're using the GCC compiler. CXX flags, which are the options that are passed to the C++ compiler when it's invoked, and LD flags, which are flags that are used for linking. You can assign values to variables by using the equal sign. So if we want to assign a value to the CXX variable, we would say CXX equals and then the value that we want it to have. For example, if we're using the GCC compiler, we probably want this variable to have the value G++. In other words, the command that we need to run for the compiler is the G++ command. If you want to substitute the value of a variable, we put the name of the variable in parentheses, the round brackets, and then put a $sign in front of it. So the value of this expression here is the value of the variable. So this would be equal to G++. As mentioned earlier, the make command is driven by the information contained in a makefile. And a makefile simply specifies targets, in other words, things that can be built by make, as well as the rules for building these targets. And in the makefile, each rule has the format or syntax that's shown here. We have targets followed by a colon, followed by what are called prerequisites, followed by commands. So what the target is for a particular rule, again, a rule is specifying how do you build this particular target. This is the thing that you're trying to build. In order to build this thing that's on the left of the colon, it may be necessary first to build some other things. In other words, it may be necessary first to build some other targets before we build this target. And this is what the prerequisites correspond to. The prerequisites are targets that have to be built before this target can be built. Then what the commands are down below here, assuming that these prerequisites have already been built, the way that we build this target from these prerequisites is we execute the commands that are listed below. And I should point out what's meant by this funny symbol here, which looks like a very large underscore character. This is denoting a tab character. And it's very important to note that the indentation here has to be by a single tab character, not by spaces. The make command cares a great deal about spaces versus tabs. They're not considered to be the same. And here these indentations have to be by a tab character. So to try to put this in context, or by way of an example, what's meant by targets, prerequisites, and commands. For example, suppose that we have a C++ program that consists of several source code files, and we have a target which corresponds to the final executable program that we want to produce. Well, in order to produce the final executable program, we need to produce this final executable program by linking together the various object files from our original C++ source code. So the prerequisites here would likely be the object files from which the executable program is produced. So in other words, first we need to produce the object files here. Then once the object files are available, we can then produce the executable program by executing a command which in this case would correspond to a command that links the object files together to produce a final executable program. A target in a Makefile is normally associated with a file of the same name, and then building the target will create that corresponding file. So for example, if I have a makefile that defines a target called X, and then I build that target X, normally this would create a file called X. However, sometimes we don't want a target to be associated with any file, so that when we build the target, it doesn't necessarily create a file that has the same name as the target. And such a target is called a phony target. In other words, a phony target is just a target that's not associated with any file. So when we build that target, it doesn't necessarily create any file. And if we want to specify that a target is a phony target, what we do is we make it a prerequisite of this dummy target called .phony. So for example, if we wanted to specify that the target called all is a phony target, what we would do is use a line which looks something like this in the Makefile, where we're specifying that all is a prerequisite of this dummy target called .phony. And .phony isn't really a target. The make utility will never build anything called .phony, but it follows the syntax of a rule in the Makefile. But the important thing is the thing that's listed as a prerequisite here is identified as a phony target by a line that looks like this. Then lastly, I just need to mention there's some special built-in variables that can be used in the rules of a Makefile. And they're just abbreviations that can save some typing, and they can be convenient for other reasons as well. The $@ symbol, this corresponds to the name of the target in a rule. The $less than corresponds to the name of the first prerequisite in a rule. So if you have multiple prerequisites, the first one is identified by this variable name. If there's multiple prerequisites, then you can identify all of them by $caret symbol. On this slide, we have an example of a Makefile that can be used to build the Hello World program, whose source code was given on an earlier slide. I'm going to assume that the source code is contained in the single file called hello.cpp, in other words, a file with this particular name here. And to begin with, perhaps I should note that the numbers in the left margin are not actually part of the Makefile. I've just numbered the lines in the left margin for convenience. So let's go through the Makefile line by line and see what it's doing. So to begin with, we initialize the variable cxx. And cxx contains the command that's used for the C++ compiler. Since we're using GCC, we want to initialize this to G++ because this is the command to invoke for the GCC compiler. Then we initialize the cxx flags variable to -g -o. -g is to specify debugging information be included, and -o is to provide some basic optimization. Then we initialize the variable LD flags, which has linker options. In this particular case, we don't need any specific linker options, so we just initialize it to be nothing. Then the Makefile goes on to define a number of rules, or specify a number of rules. The first rule is a rule to build the target all. The thing on the left of the colon is the target. The thing on the right are the prerequisites. So we have a rule for building the target all, which has the single prerequisite called hello. And the commands that are executed for this rule, there's none. You can see there's no lines that are indented by tabs below here, so there's no commands at all associated with this rule. Then we have a rule for building the target clean. This particular rule has no prerequisites because there's nothing to the right of the colon here. And there's a single command associated with this rule, which is the command rm, which removes a file in Unix. -f says remove the file even if you don't have write permission. And also, if the file doesn't exist, the command won't return a failure code. It will consider it to be successful. And the files we want to remove are the file hello and anything that ends in .o. In other words, all the object files. Then the next rule that's specified in the Makefile is a rule for building the target hello. It has a single prerequisite, which is the prerequisite hello.o. And there's a single command associated with this particular rule, which is this command here. And if we look at what this command is going to do, here we're using the value of some variables. This is using the value of the cxx variable from above. This is using the value of the cxx flags variable from above. And this is using the value of the LD flags variable from above. So the command will look something like this. This will be replaced by G++. This variable here will have the value -g space -o. Then we specify -o because we want to perform a link operation specifying an output file. So the output file is specified by the -o option. So the output file is what's given here. We could actually type the file name hello, because when we're building this target, we actually want to generate the file hello. So we could say -o and then specify for the file name hello. But instead, we're using this $@ symbol. And what this is just a short form, a predefined variable which is equal to the name of the target. So this variable here is just equal to whatever is on the left of the colon, which in this case is hello. So we could actually type hello here, but it's much shorter just to type $at. And then $caret symbol, this is also another abbreviation. This is an abbreviation for all of the prerequisites for the rule. So in this case, there's only one prerequisite, this thing to the right of the colon, hello.o. So this variable here, $caret, is equal to hello.o. So it's as if we typed hello.o here. And then LD flags, this variable is just an empty variable. It was initialized to be empty above, so this just gets replaced by nothing. Then if we continue on here, we have this .phony directive. This is specifying that the target all and the target clean are both phony targets. So in other words, when we build the target all or we build the target clean, neither one of these will produce files called all or clean. And then lastly, I have some commented out rule here. It's a rule for building the target hello.o, and it has a single prerequisite hello.cpp. And what will happen is this will hello.o will be built by executing this single command, which runs the C++ compiler G++ with the flags specified by our variable cxx flags. We specify the -c option because we want to compile. And then $less than, this is another abbreviation. This is a built-in variable, and what this means is it's whatever is the first prerequisite that's listed to the right of the colon. In this case, there's only one, so the first prerequisite is just hello.cpp. So $less than is the same as typing hello.cpp. Now this last rule is commented out. It turns out that make will automatically infer that this rule is present. In other words, it will implicitly derive this rule. So this is why I've commented out. It's not necessary, even with it not there, make will automatically infer this particular rule or add this rule for you. But just so that I can refer to it, I've listed it here. In this Makefile, there are really two main targets, the target all and the target clean. The target all is defined by this rule on line 9, and the target clean is defined by this rule on line 13. If you go back to the all target, the intention behind the all target, when we build the all target, we want to build all of the programs that are handled by the Makefile. And in this case, there's only one program associated with the Makefile, which is the hello program. The clean target, on the other hand, the goal of the clean target, when we're building the clean target, what we want to do is you want to remove all the executable files and object files that are produced by the build process. In other words, we want to clean up and leave things as they were before we compiled or linked anything. Let's consider now what happens if we run the make command and we tell it to make the target clean. What's going to happen is the make command will open the Makefile and basically read the contents of the Makefile into memory. And then it will go scanning through the file looking for a rule that tells it how to make the target clean. And when it's reading through here, you'll see it will see this line here, line 13, and line 13 gives a rule for how to build the target clean. So it will say, okay, to build the target clean, first I have to build the prerequisites, the things that are listed to the right of the colon. Well, there are no prerequisites listed to the right of the colon, so it's done building the prerequisites because there aren't any to build. And then what it will do is it will execute the command that's specified for this rule. So it will run the remove command, which deletes files, and it will delete the file hello and delete all the files that end in .o, which has the effect of getting rid of all of the executable files and object files that are produced by compiling and linking the hello program. Finally, let's consider what happens when we try to make the target all. So if we invoke the make command and we specify for the target to be built, the all target, what's going to happen? Well, what's going to happen when the make command first starts up, it's going to read the Makefile. Then it's going to look through the Makefile for a rule that tells it how to build the target all. And what it's going to find is on line 9 of the Makefile, there's a rule that specifies how the target all should be built. To build the target all, we first have to build the target hello, which is the prerequisite for this rule. So then the make command will go looking for a rule for how to build hello, and it's going to find the rule on line 17, which tells us how to build the target hello. And to build the target hello, we first have to build the prerequisite hello.o. So we have to build this target first. Now at first it might seem at this point the make command is going to get stuck because it's going to go looking for a rule to build the target hello.o, and there is no target in the Makefile that specifies how to build the target hello.o. Keep in mind that these lines down here are commented out, so they're not actually part of the Makefile, they're just a comment. What's going to happen is Make is automatically going to generate a rule for us, and effectively what it's going to do is it's going to add these two last commented lines for us, even though they're not explicitly there. It's going to generate a rule that allows us to build the target hello.o from hello.cpp. In other words, it's going to automatically generate a rule which will compile the source code file hello.cpp to produce the corresponding object file hello.o. And in particular, the rule that it's going to automatically generate will look like what's commented out here. In particular, the command it's going to run, it will run whatever command is specified by the cxx variable, which in our case is g++, and it will specify whatever flags are indicated in our cxx flags variable, which is going to be -g space -O. Then it's going to specify the -c option to say that we're performing a compile operation with the g++ command. And then $less is just an abbreviation for the first prerequisite, which in this case is hello.cpp. So this command is going to be something like g++ -g -o -c and hello.cpp. So it's simply going to compile hello.cpp to produce the file hello.o. But again, these lines here we don't need to add. This rule will be automatically generated for us by Make. Make has a large number of built-in rules. It basically knows how to compile pretty much every programming language you can encounter, including C++. So it knows how to generate object files from various different types of source code files. So you could put this in, but it won't change the behavior if you uncomment lines 26 and 27, because Make effectively adds these lines for you. So if we kind of go back to the beginning and trace things through, what happens is to make the target all, we have to make the target hello. But to make the target hello, we have to make the target hello.o. But to make the target hello.o, we need to have the file hello.cpp compiled. So the Makefile essentially generates what we call a dependency chain, or a chain of dependencies. So all depends on hello, which depends on hello.o, which depends on hello.cpp. So once this chain of dependencies has been established, that in order to build all, we have to build hello, and in order to build hello, we have to build hello.o, and hello.o essentially comes from hello.cpp being compiled. Once Make has identified this chain of dependencies, what it does is it starts at the rightmost one, the furthest one along here, and it starts building things sort of in the backwards order from right to left. So first it needs to build hello.o from hello.cpp, and to do this it would use this rule here, which it automatically generates for us. Then to generate hello from hello.o, we would use this rule here on lines 17 and 18. And then to generate all from hello, we'll use the rule on line 9. However, there's an additional wrinkle here, which is that Make performs an important optimization, which is that it only builds things that really need to be built. So for example, when it goes to generate the target hello.o, it will first check to see if the file hello.o exists. If the file hello.o exists, or if it doesn't exist, I should say, then we have to compile hello.cpp to produce hello.o, because if hello.o doesn't exist, we obviously need to produce it. However, if hello.o does exist, what happens is rather than just blindly compiling hello.cpp to reproduce the file hello.o, what Make will do is it will compile compare the modification times of these two files. It will compare the modification time of hello.cpp to the modification time of the file hello.o, and it will check to see which file is newer, which file has been modified more recently. And if the file hello.cpp has been modified more recently than the file hello.o, what this means is that we've changed the source code file since the time that we last compiled the file hello.cpp to produce the file hello.o. So if hello.cpp has a newer modification time than the file hello.o, then Make will actually generate the file hello.o using the rule that it automatically generates down here. If, however, hello.o is newer than hello.cpp, meaning that we haven't changed the source code file since the time we last recompiled the file, in this case, Make won't do anything. It will just use the file hello.o that's already there and not do a compilation operation at all. Then it proceeds on to considering this next pair here. In other words, it will consider how do we build hello from hello.o. So first it will check to see if the file hello is there. If it's not there, then it will use the rule given down here on line 17 and 18 to actually build the file hello. If, however, the file hello exists, before just blindly applying this rule down below, what it will do is it will compare the timestamps on the file hello.o and hello. It will compare the timestamps on these two files. And if the file hello is newer than the file hello.o, it won't do anything. Make won't do anything, because what this means is that this file was generated after this file was last modified. On the other hand, if hello.o is older, it has an older modification time than hello.o, what that means is that this file is out of date, that the source code and subsequently the object file changed since the time this file was last generated. So in this case, we would need to regenerate this file, in which case make would actually invoke the command that's listed in this rule down here. And then in the last case, we have once hello is built, then we need to build the all target. In this particular case, since all is a dummy target and there's no commands listed here, we're just automatically done. There's no timestamps to compare because all is a phony target. It's not associated with any file, so there's no timestamp to compare, and there's also no command in this particular rule here on line 9 that needs to be executed, so we would just be done at this point. So make is based on this idea of dependency chains. And this is a really fundamental rule with many different types of software building systems. Make is one example of a software building system, but there's lots of other software. But all of them have built into them in some way this idea of dependency chains, establishing that one file depends on another file, which depends on another file. And then based on this chain of dependencies, it figures out what are the different things that it needs to do in order to produce whatever you're asking it to build. To briefly summarize the example on the previous slide, we had a Makefile that provides an all target, and the all target builds all the programs that are handled by the Makefile, which in this case is the program called hello. We had a clean target, which removes all the executable files and object files that are produced by the build process, which in this case were the files hello and hello.o. And although the all and clean targets have no special meaning to Make, it's a very common convention to provide these targets because it allows you to make everything that the Makefile knows how to build and also clean everything up without actually having to look at the Makefile. You just know that the target all will build everything in the Makefile, and clean will always clean everything up, and you don't have to look at the Makefile. So it's very convenient to have these particular targets always defined. And we had a hello target, which compiles and links the hello program. And we talked about the chain of dependencies in the example for the all target, which was what's listed here. And all and clean were examples of phony targets, because when you make all, it doesn't actually build a file called all, and when you make the target clean, it doesn't actually create a file called clean.